Michael? Michael, you may have to unmute your mic. It starts off in a muted. I can't hear you. I don't know if you can hear me or not. And also, does that computer have a microphone and speakers on it? I'll call you. Michael?
Yeah.
On your GoToMeeting control panel, you need to go down to the audio and click on mic and speakers or use computer audio, whatever it says.
I did click on computer audio. The bubble's filled out. It's just not working.
Okay. We'll use the audio of my phone if that works okay for you.
Yeah, this is fine.
You still see my screen? Because it just went offline. What number? What number did I just write?
It's like frozen.
Yeah. Is there a reason you're using a different computer?
I'm at my mom's.
Okay. What kind of computer is it?
Some crappy one.
It's not an Apple?
No.
And it does have a mic and speakers?
I think so. I know it has speakers, so I'd assume it has a mic.
Tell you what, because it has you offline, see if you can log out while I'm on the phone with you. Click on the X of that box. See if it exits you.
Hold on, the computer is frozen.
Completely?
Yeah.
So you're going to have to reboot.
Okay, hold
on. That's going to take about 8 minutes. I know from experience. Which is okay, but I do have an 8 o'clock appointment also. What kind of problems are you dealing with? I'm wondering if we can just deal with them verbally, or you have to be able to see my screen. I've always considered it a necessity to have a drawing tablet, but given the time constraints, maybe not.
We're just now dividing, multiplying, and adding fractions.
Okay.
Hold on, I have a sheet that.
Why don't you go ahead while we're talking? Go ahead and log out or reboot your computer. Get it started, and then we can keep talking. When you say fractions, do you mean 1/3 plus 1/4, or do you mean 1 over x plus 1 over y?
Yeah, like that.
Okay.
Like one that's multiplied is like x squared minus 4 over x plus 3 times x squared plus 4x plus 3 over 2x.
That's a little different. Yeah, we're going to need a drawing tablet on those. Because the solution on those is factor everything. Go ahead and give me that one again. X squared minus 4 in the numerator.
And then that's over x plus 3.
Just that?
And then times x squared plus 4x plus 3 in the numerator.
Well, hold on. Okay. Over what? Over anything?
Over 2x minus 4.
Okay. Are you looking at that on paper in front of you?
Yeah.
Okay. I can factor the top left, and I can factor the top right, and I can factor the bottom right. Factor the top left for me. What's that called? Difference of,
Squares.
how does it factor?
The top right?
Top left.
Top left. So that'd just be x plus 2, x minus 2.
Okay. Write that. Put x
right.
plus 3 underneath it. And now, multiplication sign, factor the top right.
Would it be...
Not a lot of choices. There's not very many factors of 3.
3 and 1? 3 and negative 1.
No?
Wait.
Okay. Let's go through that.
4 and negative 1.
No, you were right. Hold on. Let's go through how you factor this. This is a very easy factoring one. You should be able to do this instantly. First of all, because that's a plus, both signs have to be the same. Because that's a plus, both signs have to be pluses. Plus, plus. It's the only way I can produce a plus 3 when I multiply these back together again. Okay? Now, I'm looking for factors of 3 that add to 4 because of that plus sign right there. Well, factors of 3 that add to 4, that's 3 and 1. Okay? Now factor the bottom right.
Would it be 2 times x minus 1 and x plus 1? Possibly.
Whenever you factor out a greatest common factor, which is all you're doing there, always make sure that when you multiply these two things back together again, you get this.
Would it be 2 times x minus 4?
No, look. Oh, that's right. You're not. I forgot. You're not seeing what I'm writing. No, it's
right now.
what when you factor out a 2, what's left over?
When you x minus 4.
X minus 2.
Oh yeah, x minus 2. That's what I meant.
Okay. So we have 2 times x minus 2 in the denominator. Now we can go to town with canceling. My lower left.
I can see your screen. I can see your screen.
Okay, cool. So we're back in business here. Hopefully it won't freeze again. So you can see everything that I've written.
Yes, sir.
And that's always the way to do these problems, is to factor, because what you're going to find is that a lot of stuff cancels. That x minus 2 cancels with that x minus 2. That x plus 3 cancels with that x plus 3. And everything left over is what you have. So you end up with x plus 2 times x plus 1 all over 2 is your answer. X plus 2.
Hold on. So,
in other words, anything that you didn't cancel out is still left.
So, what would the top be? Would it be like x squared times?
Can you? Well, don't multiply it back together again. This is a better answer than if you multiply it back together. Why? Because frequently, if you had multiplied it back together, the first step is to factor it. So it's actually a better answer in factored form. This is your proper answer right here. Okay?
And then just FOIL that, so...
No. This is the final answer.
That is?
Yes. In other words, it's better to leave it in factored form than it is to multiply it out. Unless you have some reason to multiply it out. In other words, let's say that on the bottom we had an x squared plus 3x plus 2. Well, now that happens to be, when I multiply these two out, that's what I get. So I could cancel that and that. But I don't have anything else, so there's no benefit of multiplying these two things together. There's no other polynomial around. Okay? Now, for the most part, all of these problems are going to be like this. Every one of them. And in a lot of cases, all four parts will be factorable. You'll be able to factor the top left, the bottom left, the top right, the bottom right. And then just start canceling. Okay? Now, there is, in general, things have to be equal. In other words, if I have this over that, I can't cancel it. Your computer froze again, didn't it?
Did it?
Yeah. Did you? I just wrote x plus 1 over x plus 2.
Yeah, it might have froze. Give it like a second.
Well, I see because it says you're offline on my end. In other words, my end tells me everybody that's in the meeting, and it's got Pamela as being offline.
Yeah, it's frozen.
So it's frozen. So given that we only have 15 minutes, why don't we just verbally finish this session?
All right.
Okay? If I have x plus 1 over x plus 2, and maybe the way we're going to have to do this is you should have a blank piece of paper and a pencil in front of you. And anything that I say, you should probably write. And that will solve the problem, actually. Okay?
Yeah. All right.
So when I have this, I can't cancel anything. Because x plus 1 is different than x plus 2. If it was x plus 2 over x plus 2, I could cancel them and I would have 1. But if they're different, you can't do anything except in one situation. Write down x minus 3 over 3 minus x.
Write down what?
X minus 3 in the numerator. 3 minus x in the denominator.
Yeah, that cancels out, doesn't it? Or
Well,
no,
almost. What's that equal to?
What?
That's equal to negative 1. In other words, it doesn't cancel out straight. The denominator is the negative of the numerator. In other words, let's rewrite it. What we had was x minus 3 over 3 minus x, right?
Yeah.
Now let's rewrite it as x minus 3 over negative sign, parentheses, x minus 3 in the parentheses.
Yeah.
Is that the same as 3 minus x?
Yeah.
Bottom? Yes, it is. So I can now cancel that x minus 3 with that x minus 3, but I still have that negative sign. So I got negative 1. So this is the only time you're going to be able to cancel stuff that doesn't look exactly the same.
Yeah.
Okay? And it's only when subtraction is happening. In other words, a minus b divided by b minus a is always negative 1. No matter what a and b are. Unless it's 0, and then you're dividing by 0. And then it wouldn't be that. But all right, what other kinds of problems can we do this way?
We have just some more versions of those.
Okay.
But this one is subtraction.
Okay, go ahead and read it to me.
X minus 1 over x minus 2.
Multiply or divide?
Minus.
Okay.
Minus x minus 4 over x plus 1.
Okay. How do we add fractions or subtract fractions that have different denominators?
Don't you try to find a common denominator?
Correct. What is the common denominator going to be here?
I mean, you could make it 2.
No. Very specifically has to be a function of the two denominators we're looking at. Let's make it easier. If I had 1 over x plus 1 over y, what's the common denominator?
1 over x over 1 over y.
1 over x plus 1 over y. What's the common denominator?
xy.
Correct. In other words, you always are going to get a common denominator by multiplying. So in our problem, what's the common denominator going to be?
X.
X minus 2 times x plus 1. So,
That's it.
In other words, that guarantees we have a same denominator. Now all we have to do is figure out what goes in the upper left numerator. In other words, once I've found my common denominator, and in general, when you have variables, you can always get a common denominator by just multiplying them together. Okay? That guarantees that when I divide that common denominator by this denominator, I get integers. Okay? I see you're coming back on here. It didn't take too long to reboot that time.
Yeah.
Can you see my screen now?
Yeah.
Okay. So what goes here?
Would that be? Wouldn't it be x minus 1?
No. The way you figure it out is you divide the denominator, x minus 2, into your common denominator, and whatever you get, you multiply by this numerator, and that's what goes there. In other words, notice if I write x minus 1 times x plus 1, have I changed that fraction? Is that the same fraction as that? And that's what you constantly need to check. Is it the same?
Yeah.
Okay, we did it right. That's all you need to do. Okay, now let's do the other part. This part over here. Well, we know there's at least an x minus 4. What's the rest of it have to be? So that it's the same fraction as that.
X plus 1?
No. If it was x plus 1, then these two x plus 1s would cancel, and I would have x minus 4 over x minus 2, which is not that. So what does it have to be so that I have the same thing? When you divide the common denominator, when you divide the common denominator by x minus 4, by x plus 1, what do you get?
When you divide x
When I divide the common denominator by this denominator, x plus 1, what do I get?
X minus 2.
That's what goes there. Now notice that I can cancel my x minus 2's, and I'm left with x minus 4 over x plus 1, which is what I started with.
So on the first one, you can cancel the x plus 1s. On the second one, you just should be able to cancel the other one?
Yeah, the point is that I'm trying to write this left fraction with this denominator. And I'm trying to write this fraction with that same denominator. So, all I have to do is figure out how to write this thing so that I don't change it.
So what would the end result be then?
Well, we're not done. In other words, at least now we have common denominators, so I can subtract common denominators. I can now subtract these two fractions. And how do I do that? I do it by combining the numerators. Well, now I need to multiply those numerators together.
Wouldn't it just be x squared
You got
minus
it.
4?
No.
And
Well, when I multiply these two numerators, that's the difference of perfect squares factored. So when I multiply it back together again, it better be x squared minus 1. Okay?
X
So
minus 1.
that's the top left.
Oh, yeah.
Okay? Now, the top right, and I need to use parentheses here. Otherwise, I'll get my sign wrong. Foil x minus 4 times x minus 2. What do you get?
If you do what?
Foil the right numerator.
X plus 1?
No. X minus 4 times x minus 2.
Okay.
Okay? Foil those. What do you get? X squared.
X squared minus 6x plus 8.
Correct. And put that whole thing in parentheses. The reason you need parentheses is because we're going to subtract that. Okay? Now you can remove the parentheses. What do you end up in the complete numerator between both fractions? In other words, once you've found a common denominator, now you merely operate on the numerator. Well, I got x squared minus 1 on the left, and I'm subtracting the quantity x squared minus 6x plus 8. What is that?
So you have what on the top left? X minus 1?
X squared minus 1.
X squared minus 1.
That's what I got when I multiplied x minus 1 times x plus 1.
Okay, and then
when I'm subtracting the results of foiling the top right,
so would it be negative plus 7?
say again?
Negative 6x plus 7?
Is it negative 6x? That's why I put it in parentheses so that I wouldn't get the sign wrong. Let's just first of all remove the parentheses. So now I have x squared minus 1 from the top left minus, removing the parentheses, I now have x squared plus 6x minus 8. You see why?
No. Oh, because it's a minus. It's
right,
minus.
Because there's a minus in front of that quadratic.
So it'd be...
That minus has to be distributed to every term.
It'd be 6x minus 9.
Correct.
X minus 9.
6x minus 9 all over that common denominator. And there's no real reason to multiply that denominator out. Don't need to. Just leave it as x minus 2 times x plus 1.
X minus 2.
I'm not going to be able to cancel anything else out. So, in other words, if I were to factor something out of the numerator like a 3, I would be left with 2x minus 3, but that doesn't help much because I can't cancel that with anything on the bottom. So the final answer is 6x minus 9 in the numerator, and in the denominator, x minus 2 times x plus 1.
Alright.
Okay.
So the final answer is 6x minus 9 over x minus 2 times x plus 1.
Correct.
Alright. Do we have time for one more?
Sure. Make sure you write it down as we're going through it, because you can't see my screen. So.
Alright, so this one is a division 1.
Okay.
4x minus 8 over x squared minus 3x plus 2.
And instead of writing the division sign, in other words, the slash with the dot above and below it, let's immediately turn it into a multiplication problem. Let's not mess with any division. So to turn it into a multiplication problem, what do you have to write? The reciprocal In other words, take the fraction that you were going to write and just switch the numerator and the denominator. What do you get?
On both sides?
Upper right.
X minus 1 over 3x minus 6.
And I'm assuming that you were dividing by 3x minus 6 over x minus 1, right?
Yeah.
So that's the same as multiplying by x minus 1 over 3x minus 6.
Yes.
So
the original problem was just that flipped.
Right. And like I said, you don't ever want to do division. Instantly turn your division problems into multiplication problems. Okay? Always. First step. Now, there's a lot of factoring. I can factor that, I can factor that, and I can factor that. And I'll bet after I've factored it, I'm going to be able to do a lot of canceling. So, factor the top left.
2x.
No, top left. 4x minus 8.
So would you divide by 4, so it'd be
Yes.
x minus 2?
Correct. So that's what the top left now looks like. Factor the bottom left.
Factors that what? Multiply to 2 and add to 3? Or negative 3?
Kind of. We don't really have time to go through factoring right now, but we should. There's nothing more important in algebra than you being able to factor. It's something you're going to have to do repeatedly. So we should do a session on factoring. I'm serious. I factor a certain way. They teach you what's called the California method or the diamond method.
Yeah, we do the diamond method too.
I don't like the diamond method. When you're dealing with simple quadratics, and I mean simple because its coefficient of the x squared term is 1, then it's so easy to factor this. Here's what I do. I separate the x's into x and x. I determine both signs as my second step. What do both signs have to be?
I don't know. One negative, one positive.
I can't produce a plus 2 unless they're both the same. If one was negative and one was positive, that would be a minus number. Okay? So both signs have to be the same, and they got to both be minus because the middle term is minus. So I got x minus times x minus. Now the third rule and the last rule is factors of 2 that add, because of the plus sign in front of the 2, to the number 3. What factors of 2 add to 3?
Add to positive 3?
2 and 1. Yeah, add to positive 3. When you're looking for factors of 2 to add to a number, don't count that negative sign. Just count the coefficient. We want factors of 2 that add to 3. That's 2 and 1. We already got our signs. In other words, that was my second step, was figuring out that both signs had to be negative. Okay? So now you should be looking at, on the left, 4 times x minus 2 over x minus 2 times x minus 1. Going to multiply that by x minus 1 is the upper right numerator. The bottom right denominator, I'm going to factor a 3 out, leaving x minus 2. Are you looking at this now on your piece of paper?
Yeah.
What cancels?
X minus 1.
That's one thing that cancels.
And the 2's?
X minus 2. I've got an x minus 2 in the numerator, and I got 2 of them in the denominator. So I can certainly take out 1. So what am I left with?
I don't know.
Okay. It's 4 over 3 times the quantity x minus 2.
over 3
times the quantity x minus 2. That's what you're left with when you cancel everything.
So that would be the final answer?
Uh-huh.
That's the final answer.
4 over 3 times the quantity x minus 2. And the x minus 2 is in the denominator.
Yeah. I'm trying one more time to get on that screen just to like see the
Well,
steps.
it's actually too late. I have an 8 o'clock that I'm late for, so I'm going to have to run.
Okay.
Okay, Michael?
All right. Thank you.
Sure. Talk to you next time.
All right. See ya.
Bye-bye.